Caves. They're a dark and mysterious place where eternal silence is broken only by the flutter of bat wings and the echoes of water droplets falling from the ceiling. Large, vaulted halls, carved out slowly by percolating groundwater, are often integrated into a network of confusing passageways, sometimes carrying large volumes of water. Tapestries of delicate and exotic-shaped calcite formations decorate hidden rooms and secret chambers that lead throughout this world of relentless darkness and trembling shadows. Strange and unusual creatures that have evolved in the world of absolute darkness no longer have color and have even lost the need for their eyes. Ancient cultures throughout the world feared caves, believing that demons and mystical beasts dwelled within these eerie realms. Only the brave dared to enter the labyrinth of subterranean tunnels that led into the unknown. But today, members of the National Speleological Society have boldly faced the harsh and often dangerous environment to document and map the vast underground wilderness that lies beneath our feet. Caves, sinkholes, and large springs are found in over 15% of the United States, as shown by the green-colored areas on the map. These cavernous limestone terrains are called Karst Topography. In our southeastern states and throughout the Appalachian Mountains, karst topography is found in large areas of the states. Many caves over a mile in length are found in Virginia, West Virginia, Kentucky, Tennessee, Alabama, and Georgia. Large caves and thousands of sinkholes and springs are also found in southern Indiana and throughout the Ozark Mountains of Arkansas and Missouri. Two other states rich in caves are Texas in the Edwards Plateau region and New Mexico, where Carlsbad Caverns National Park is found in the Guadalupe Mountains. Many of the early towns and homes in America were settled near large limestone springs as a source of good drinking water. Unfortunately, as our nation grew, people began throwing trash and even hazardous waste into sinkholes, resulting in widespread spring water pollution. As our population increased, homes were even built inside of sinkholes, which commonly flood during large storm events. And another problem with building too close to a sinkhole is the risk of sudden collapse and damage to a home. Understanding the causes for spring water contamination, sinkhole flooding, and sinkhole collapse are essential for preventing future problems. Karst photography forms where limestone or its near equivalent dolomite is found at or near the surface. But where did all this limestone come from? Millions of years ago, the warm waters of a shallow sea covered much of the United States. In warm seas, such as in the Bahamas today, coral reefs are abundant. Coral and the shells of other sea creatures are composed of the mineral calcite. Through geologic time, the coral reefs and surrounding limy muds are converted to the rock we call limestone. Unlike most rocks, limestone can be slowly dissolved. Carbon dioxide in the atmosphere combines with rainwater to form a weak natural solution called carbonic acid. As the acid-rich rainwaters move through cracks and pores in the rock, the limestone is slowly dissolved away. Given thousands of years, the small cracks called joints can be enlarged to open fissures that usually lead downward to caves. Circular-shaped depressions called sinkholes are another manifestation of the dissolving power of rainwater. Most sinkholes form by the slow dissolution of rock, but some sinkholes form when the underground drainage system removes part of the underlying bedrock support. As the roof above a large cave room slowly collapses upwards, it may breach the surface. The Devil's Sinkhole in Texas is an excellent example. In rare cases, an ancient cave roof collapse forms a deep sinkhole that allows us to view a small segment of the underground drainage. The cave stream emerges as a spring on one side of the sinkhole and then quickly disappears at the other end. In some cases, the carbonic acid-rich groundwater can carve out enough rock to produce large underground caverns. As the water table slowly drops through geologic time, groundwater drains from the caves, filling them with fresh air from newly formed sinkhole entrances. Groundwater rich in dissolved calcium still drips into many caves. Drip by drip, crystals of calcite are deposited to form a vast array of spectacular formations such as stalactites and stalagmites. Throughout most of the year in karst regions, creek beds are dry. But during the wet season and after large storms, the open fractures and sinkholes in limestone areas enable storm waters to rapidly sink into the subsurface, where they move through a network of passages to form cave streams that emerge as large springs, common throughout karst terrains. On the surface, most people never think about the groundwater beneath them. Little do they know that many human activities have the potential to degrade our drinking water supplies. But when people see the cool, clear spring water emerging from the side of some hill, they just want to sit down and have themselves a drink. Unfortunately, limestone spring water is seldom safe to drink without treatment. In karst areas, storm waters usually enter the subsurface too rapidly to receive adequate filtration of surface contaminants. Once the polluted water enters the cave stream, little or no additional filtration takes place before it reaches a spring. Hydrogeologists specializing in tracing groundwater use harmless dyes to help understand the subterranean flow paths in karst terrains. If a spring becomes contaminated, karst hydrogeologists can use fluorescein green dye, or red dyes such as rhodamine or eosine to prove a connection between a pollution source and the spring. Packets of highly absorptive charcoal are placed in the spring, where the dye, if present, is slowly absorbed and can be easily tested for in a laboratory.